Hey everyone, and welcome. Today, we are diving into one of the most fundamental ideas in all of science, the difference between a physical and a chemical change. And I know, it might sound simple, but this one concept, it explains pretty much everything that happens around us.
So, just think about this for a second. If you take a piece of paper and you rip it in half, you've changed it, right? And if you take that same piece of paper and you light it on fire, you've also changed it. But we all know instinctively that those are two completely different kinds of transformations. So what's really going on? What's the actual difference? Well, we're about to find out.
So here's our game plan. We'll start with the basics in A Tale of Two Changes. Then we'll look at changes that are just on the surface. After that, we'll get into what happens when something completely new is made. I'll give you a detective's toolkit to tell them apart. And finally, we'll see why all this science really matters in your daily life. All right, first things first. Before we can even talk about changing something, we have to be super clear on what that something actually is. And in science, that something is called matter. Now, that's a simple definition, but it is huge. Matter is, literally everything. It's the phone or computer you're looking at, it's the air you're breathing, it's even you. And all matter has properties, kind of like a personality, that lets us know what it is and what it can do. So let's ease into this and start with the more familiar side of things, physical properties. Just think of these as the characteristics you can see or measure without actually changing what the stuff is made of. And that right there is the absolute key phrase in the definition, without changing the identity of the substance. You can look at it, you can weigh it, you can describe it, but the stuff itself stays the same. And here are some classic examples. You can describe a rock's color or its shape, but it's still a rock. You can measure its mass or density, still a rock. And think about an ice cube. Yeah, it looks and feels totally different from liquid water, but we all know it's just frozen H2O. Its state changed, but its identity didn't. These are all physical properties. So, this leads us right to the idea of a physical change. When something goes through a physical change, it might look different on the outside, but its chemical identity, its core recipe, that stays completely untouched. Let's look at this in action. When you melt an ice cube, it goes from solid to liquid, but it is still H2O. Crush an aluminum can, it's just a crumpled up piece of aluminum. You cut paper, you break glass, you've changed the form, but you have not created a single new substance. Okay, so that's the physical side of things. Now let's get into the really transformative stuff. Chemical properties. They aren't just about what a substance is right now. They're all about its potential, about what it could become. And that is the critical difference. A chemical property describes a substance's ability to completely rearrange its atoms and become something entirely new. We're talking about a total transformation. Now, what's really fascinating here is that you can't just look at a piece of wood and see its flammability. You only observe that property when you actually try to burn it, right? Same thing with iron's ability to rust. You only see that happen when it's exposed to oxygen and water. And when those chemical properties get a chance to show themselves, we get a chemical change. And this is not just a new look. It is a fundamental change in identity. The atoms literally break their old bonds and form new ones to create brand new molecules. Just look at these. When you burn wood, you can't unburn it. There's no going back. You're left with ash and smoke, totally different substances. You can't uncook an egg. The original flour, sugar, and eggs in a cake are gone, replaced by a delicious new creation. A chemical change has definitely happened. Okay, so you've got a change happening right in front of you. How can you be the science detective and figure out which kind it is? This is where we get the tools to solve that paper mystery from the beginning. This is it. This is everything. This is the single most important question you can ask. If you can answer this one question, you can tell the difference every single time. It's the absolute heart of this entire idea. And here it is, the ultimate cheat sheet. If no new substance was formed, like when we melted that ice cube, your answer is no. It's a physical change. If a brand new substance was formed, like when we burn that wood, your answer is yes, it's a chemical change. It's that simple, that direct, and that powerful. Okay, but how do you know for sure if a new substance is actually formed? I mean, sometimes it's obvious, but other times you have to look for clues. Think of these as the telltale signs that a chemical reaction has just gone down. So, if you see an unexpected color change, like metal starting to rust, that's a clue. If you see bubbles of gas, but you're not boiling anything, another clue. If something gets hot or cold all by itself, or produces light like a firefly, or creates a new smell like baking bread, these are all giant signposts screaming, chemical change is happening here. So let's just put it all together one last time, side by side. Physical properties describe what a substance is, its shape, its color. Chemical properties describe what a substance can do, its ability to burn or react. But if you only remember one thing from this whole explainer, make it this. Physical changes create no new substances. Chemical changes always do.
Now, I know this might feel like a basic science lesson, but honestly, understanding this difference is fundamental to almost everything, from super high-level chemistry to what you do in your kitchen every day.
I mean, scientists use these principles to create new medicines and materials. It's how we understand and control powerful reactions. It's the reason you know not to mix certain cleaning chemicals at home, and it's literally how we cook our food. This stuff really helps us understand and kind of manipulate the world around us. And to bring it all home, just think about this for a second. Every breath you take, every bit of food you digest, every single thought firing in your brain, it's all powered by an endless cascade of chemical changes. Your body is the most amazing, sophisticated chemical factory on the entire planet. So, what reactions are happening inside you right now? Thanks for joining me on this one.